So here we have a power being raised to a power, right? So what do we have to do with those exponents?
Multiply.
Multiply, very good. Sometimes it's tempting to add them, but that's not correct because let me just remind you why. X to the fourth to the third power, right? If you're just dealing with that for a second, just pretend that was the whole problem, is really like saying x to the fourth times x to the fourth times x to the fourth. So yes, when you multiply, you get to add the exponents here and you would get x to the 12th. But then how did we get that from the original problem? We actually multiplied the 4 and the 3, right? So that's where it comes from.
Mm-hmm.
So it's x to the 12th, and then it would be y to the
15th.
15th. I always encourage that though. Let's say you get confused and you start forgetting the rules. You can actually write the problem all the way out, because even for this one, if you got to this step and you still weren't sure what to do, well, you know x to the fourth is like 4 x's, right? And then this one is 4 x's, and then this one is 4 x's, right? And you could be like, okay, well, how many x's are there? There's 12, right? So, I mean, you can break these problems down without the rules, but I don't recommend that because it's going to take forever. But if you're forgetting the rules, you can at least do it once to kind of remind yourself. If you're ever like, which one is it? Do I do this or this? You can kind of check yourself the long way. Okay, so let's do the next one. Keep in mind, if you have a negative exponent and you square it or you raise it to any even power, it's going to become positive, right? Because a negative times a negative is a positive. But if it was a negative being raised to an odd power, then it would stay negative. Okay, so this one's going to be positive, and then what is 5 squared? You just deal with the number like normal.
Maybe 25.
25, and then what would the rest of it be?
A to the 6th,
Mm-hmm.
B to the 8th, C to the 2nd.
Good. Okay, how about number 3? What would that answer be?
R to the 4th over S to the 4th.
Good. Good, good, good. Just apply the power to each part of the fraction. Good. How about number 4, 12 to the 0 power?
Be 1.
1. Anything raised to the 0 power is 1. So what about negative 6x in parentheses to the 0 power?
1.
1. Okay, what about number 6?
Negative 2.
The answer is negative 2. Very good, because you could think of it, because the negative 2 is not in parentheses with the x, that this is really like saying negative 2 times x to the 0 power. And by the order of operations, you deal with the exponent first, which becomes 1 times that negative 2. So you're absolutely right. The answer there is negative 2. Very good. That's a very challenging problem because most students at this point are used to thinking, oh, there's a 0 power, so the answer is 1, but you're missing the fact that that negative 2 is not in parentheses. So awesome. You did not fall for it. Number 7 is also a very challenging problem, not because it's hard to evaluate, but it's hard to figure out the sign sometimes. So what is the answer to number 7?
It's negative 1.
Very good, because once again, technically, like in the last problem, we could separate a negative 2. This negative out front, you could think of as a negative 1 times whatever is being squared. So in this case, 1 is being squared, but no matter what that number was, you could separate the negative 1. So you're absolutely right. Your answer is negative 1. So the parentheses or the lack of parentheses is really important, because if I gave you this problem, negative 1 in parentheses squared, what would the answer be?
1.
It'd be positive.
Exactly. Mm-hmm. So, great job. Okay, number 8. How would you simplify that?
You like divide by like the single terms.
Yeah, so I would focus one term at a time. Focus on the constant, focus on the x's, focus on the y's, focus on the z's. Very good. So when you start with the constants, there's an 8 and there's nothing else. So the answer is going to have an 8 in it, right? And then what is x to the 4th divided by x squared?
X squared.
X squared, right? Because when you're dividing, what do you get to do with the exponents?
Subtract.
Subtract them, which is just based on the idea that like if this is x to the 4th, right, and this is x squared, well, you're canceling these all out and you're left with the x squared, right? So if you're trying to write it out the long way, that's what's going on. But you're absolutely right. The answer is x squared. Okay, what about for y?
Just y.
Just y. 2 minus 1 is 1, and you don't have to write the 1 as the exponent. It can be assumed if there's nothing written there. And then what about the z's?
And they cancel out.
Perfect. So that would be your answer, 8x squared y. Okay, number 9. What would you like to do first there?
You cube everything.
Okay, let's do it. What do you get when you cube everything?
So you get 9u to the 18th.
Okay, so not quite 9 because you're not doing 3 times 3 because the 3 is a constant.
Oh, my bad.
So you're actually doing 3 to the 3rd power.
Yeah, so you get 27.
Mm-hmm. You were right about the u to 18 power. Good. And then for the denominator,
you would get 729 v to the 15th.
Good. Now, unfortunately, those actually simplify because I believe, and I say unfortunately only because you might not see it, but I believe, yes, 27 goes into 729 27 times.
So then could you have broken that down before you did
yes.
Okay.
Yes, so the way we did it gives you bigger numbers, but you can still simplify them if you use your calculator. What I just did there was I divided 729 by 27 and saw that it divided evenly.
Okay.
So you could still figure it out even with a basic calculator. But yes, what you could have also done in the original problem is recognize that 3 and 9 are both divisible by 3. So you
just
could have
did
divided
1/3.
The original, so that would have just gone away and this would have become a 3. And then when you cubed it, that would have led directly to that answer.
Okay.
Mm-hmm.
And I realized that after I did it, that I could have just done it easier.
But it's good to realize, I always emphasize when I'm teaching these lessons that there are multiple ways to do these problems and that's okay, right? We're not all going to think the same way. Sometimes you might think to reduce, sometimes you might not, and it's okay. Like don't freak out and think, why didn't I think of that or whatever, just keep going. Yeah. And then sometimes it's also okay if you can do the same problem 2 different ways, but you get the same answer both times. That should be reassuring that you've done it correctly, right? So that's also a great way to kind of check yourself. So that's awesome.
You bring them down to the denominator.
So if it's negative in the numerator, you bring it to the denominator. If it's negative exponent in the denominator, you actually bring it to the numerator. So you get to switch the position. Just to make sure you understand where this comes from. Let's say you had the problem x squared divided by x cubed, right? Let's work it out the long way for a second, okay? So I put 2 x's up top, 3 x's in the bottom, kind of like I've shown you with some of the other rules, right? And so let's cancel out the x's. What are we left with? Where is there an x?
The denominator.
Yeah, so we're clearly, if you work it out the long way, that was not what I wanted to do. Clearly left with the answer 1 over x, right? Do you see that if we work it out the long way? Okay, but if we use the rule that we've also learned before that you can subtract the exponents, right? So let's try this problem a different way. What is 2 minus 3?
-1.
So by default, doesn't that mean that x to the -1 has to be the same as 1 over x? Because we know these answers have to be equivalent, right? So that's a way it kind of helps you see where did that come from or how did we create that rule? Like if it feels random, maybe that helps it make a little more sense. Okay, so here, does the 3 move in number 21?
No.
No, why not?
Because the exponent is only on the x.
Very, very good. So the 3 actually stays in the numerator, but the x moves to the denominator, gets an exponent of +1, but of course we never write exponents of +1, so we just write it as x. So your answer there would be 3 over x. Okay, number 22. There's a few ways to approach this, so I'm actually curious. What would you guys like to do first in number 22?
I always just distribute the 3 into the fraction.
Okay, so explain what you would do then.
1 to -3 and then 5 to -3.
Mm-hmm. Okay, just make sure that you put the negative somewhere, because if the exponent was positive, or just know the rule that this is going to stay negative because we're dealing with, yeah, okay. Just make sure you know that that negative technically is also being raised to the -3, but it stays negative because of the odd number.
Yeah.
Okay, so yes. So you could even put the negative somewhere if you wanted to, but you don't have to if you just know what's going to happen. So 1 to the -3 and 5 to the -3. That works. Then what would you do from there?
Then you would do 1 times 1 times 1. And then
Okay.
5 times 5. And then put the negative because it's only 3 times, so the negative stays.
Okay, but be careful because these aren't being raised to the +3 power. They're being raised to the -3 power.
So you switch them?
So you switch them. So you could either switch them now and say, okay, the negative's there. So this is going to actually be 5 cubed over 1 cubed, right? You switch them to make the negative exponent positive. You put it in the opposite position. So I took this negative exponent and put it down here. Took that negative exponent, put it up there. Then you're absolutely right. You get 125 and 1. And of course, 125 divided by 1 is
125.
125 with the negative still in front. Marla, did you have a question? I see your lips moving, but I can't hear you.
Sorry, could you pull that negative out?
Pulled what negative out?
Like, I don't know. Since it's like, could you pull the negative out and then did like I don't know, maybe it would have been easier to see.
Okay, so there's a few ways you can do it. So I'm not sure if this is what you're asking, but let me see if this addresses it or not. Because there were definitely, I can think of at least 2 other ways that we could have approached this problem. One way would have been that if you have a negative exponent and a fraction, one trick you can do is flip the fraction to change the exponent from negative to positive. So as your first step, you could have actually rewritten this as -5 over 1 to the +3 power. And then 5 over 1 is just 5, so you could have actually just done like -5 to the 3rd power, which would have still given you that answer of -125. Okay, another way you could have done it is rewritten it like, said, okay, the negative exponent means I move it all to the denominator. So you could have written it as 1 over -1/5 to the 3rd power. Worked that out. It would have given you 1 over -1 over 125. Then you would have used keep, flip, change to keep the 1 the same, multiplied by the reciprocal of the denominator, and you still would have gotten -125. So those are 3 completely different ways that you could have gotten the answer. So does that help? Does that answer your question at all? I'm not sure if I did or not.
Yes. Yeah.
Okay. So once again, with these problems, you will notice there's a lot of ways to do the same problem, and that's okay. So what about number 23? What do you guys want to do first there?
Don't you add the 9 and the 3 together?
It's a great first step. Yep. So if you add 9 and 3 together, what do you get?
X to the 12th.
Good. And then we have to divide, right? So when you divide, what do you do with the exponents?
You subtract the 6 from the 12.
Good, which gives us x to the
6.
Very good. Okay, number 24. I want each of you to try this one on your own because I'm curious to see what each of you do, and then we'll go over it together in a minute. So what did you do first? I'm curious.
So I brought the r to the -9 and 4 to the top.
Okay, that is one way to do it for sure. So now you have r to the +9, r to the +4 because you got rid of both negatives by bringing them up. Okay, and then what would that give you as your final answer, Marla?
I got r to the 14th.
Good. Caitlin, did you do it that way?
No, I did it a different way.
Okay, what did you do?
I did r to the 9th minus r to the 4th to get r to the negative 13th.
Good.
I did, and then I added, well, subtracted, but since it's a negative, you add. So I did 1 plus 13 equals r to the 14th.
Mm-hmm. Yep, because 1 minus negative 13 is really 1 plus 13. Good. So that's a great example where you both used completely valid methods that look completely different, but get you to the right answer. So I was curious because those are the two ways I normally present this. I was curious if you guys would do them the same way or what you would pick. So that was cool. You each did it one of the ways. Okay. How about this one? How would you approach number 25?
I would just divide the negative 15 and the negative 3. And then I can see that 7 minus 6 is just 1. So then you just put m next to the 5.
Okay, number 26.
So I would bring the y and the x to the denominator.
Okay.
Oh, I'm sorry, the x to the first power, not the x to the fifth.
Yes, yes, I understood.
Okay.
You're good. I think I did it right. Yes. Okay. Then what would you do?
I would just go ahead and multiply the 5 by the 4 on the top to get the negative 20.
Mm-hmm.
I would, oh, that also checks out. Okay, so then it would be negative 20, x to the 4th.
Mm-hmm. Because you're taking
on the top
to the 5th divided by x. Good. Mm-hmm.
On the top, and then the denominator would be y to the 2nd.
Good, because you could think of it as either 2 minus 4 gives you negative 2, which is the same as saying y squared in the denominator. Or you could think of it as, okay, if we're just like canceling them out, there's obviously going to be 2 left in the denominator. Good. Now that's not the only way you could do it, by the way. Since we're multiplying, you could add the exponent. So you would get negative 20, then you would add the 5 and the negative 1, which would give you the x to the 4th that we end up with. And then you also could add the negative 4 and the 2, which gives you negative 2 as your exponent, which is why there's a y squared in the denominator. But I love what you did, Marla, because if it helps you to visually see it like this, by all means, go for it. That's perfect. So there's, like I keep saying, many ways to do these problems. Okay, number 27. What could we do there?
Distribute the negative 5 to the exponents.
So what would that give us?
A to the 15th.
Mm-hmm.
And then b to the negative 40.
Okay, is that my final answer?
No.
No, why not?
Because there's a negative exponent.
Mm-hmm. And it says use positive exponents only. Good. So how would you write the final answer?
A to the 15th over b to the 40th.
Good. The negative exponent becomes positive by moving it to the opposite position. Perfect. Okay, how about number 28?
You don't do anything to the constant.
Correct, because they don't divide. So I like that you saw that, because sometimes we start using exponent rules on constants and it doesn't work like that. You work with constants just like normal numbers, right? So since 4 doesn't go into 5, you just leave all the constants alone. You might see them move the negative to the front, but that's just like a style preference. It doesn't mean it has to be there. Okay, then what about the x's?
You subtract them.
Mm-hmm.
You just get x.
Mm-hmm. And then the y's?
You get negative 3.
Mm-hmm.
And then you'd move that to the denominator.
Exactly. And then that would be your answer. Nice job. Okay, number 29. This is another one where there's definitely several ways to approach it. So who would like to tell me one way to approach this problem?
I would like multiply the negative exponents, distribute it.
Mm-hmm. So what would that give you?
Then the numerator, you would have a to the negative 10th, b to the positive 25th.
Good.
The denominator would be positive 4.
Okay, so be careful there. Let's just go ahead and keep distributing and then we'll evaluate because there's a reason I'm saying that. So it would be 2 to the negative 2 power, right?
Oh yeah, true, because that would go to the top. Okay.
Yeah, so you are going to get 4, but you're right, it'll go to the top.
Yeah.
Yeah.
And then it would be a to the negative 4.
Good.
And then b to the positive 2.
Awesome. And then, yes, you already nailed it on the head. 2 squared is 4, but because of the negative exponent, it goes in the opposite position. So for the constants, you're now going to have a 4 in the numerator. Okay, then what about for a?
The a to the 10th would go to the bottom, and the a to the 4th would go to the top.
You can do it like that. Yep. And then
for
the
b's, they would both stay the same.
Okay.
But you would subtract the 2 from the 25, so you get b to the 23rd on the top.
Good. And then we just have to finish the a's.
Yeah, so then you would get a to the 6th on the bottom.
Good. And it is okay. I could tell you were like, oh, whoops, I'm not done yet. It's okay, right?
I know. I always do it like that. I work out the whole thing.
But that's okay because it doesn't matter if it takes you 3 steps and Caitlin 2 steps, and someone else 7 steps. It doesn't matter, right? It's not a competition of who can solve it the fastest as long as you can all do it in a reasonable amount of time. So that is perfectly fine. So Caitlin, are you doing okay?
Yeah, I would have done it pretty much the same way. Besides, I don't switch the
the negatives to positives.
Yeah, I wait till the end to do that.
Yes, you would have subtracted and gotten -6 and then moved it down, right? That's what you did in another problem. Yeah, but that's perfectly fine. As long as you can follow what we're doing and getting the same answer, then that's what matters.